What's going on, guys? So this is your work for Tuesday and Wednesday, maybe a little bit into Thursday as well. This is 6-4. This is constant rate of change. So I start us off with a music example. They tell us Marcus can download 2 songs from the internet each minute, and they give us a handy dandy table to illustrate this fact. All right. So they ask us in step 1 to compare the change in the number of songs Y to the change in time X. What is the rate of change? Well, they tell us in words. They say he could download 2 songs from the internet each minute. So that's expressing it to us in words. Then we see right here, we go from 0, 0 to 1, 2. So every time we're increasing by 1 here with our X, we're increasing by 2 with our Y. All right, so there's a consistency right there. So if we are adding or subtracting the same value, then we have a linear function right there that we're working with. And not only do we have a linear function, we have the specific slope or rate of change for this function. So the rate of change right here is 2. And what that tells us is that for every minute, his rate of change is 2 songs. So what is the rate of change? So the rate of change, our M, is 2, but that's in songs per minute. Then they ask us in number 2 to graph the ordered pairs from the table on the graph shown, label the axes, then describe the pattern shown in the graph. Well, describe the pattern shown in the graph, guys. That's a little bit repetitious right now because we're having to recapitulate something that we were given in the first sentence, and then we were asked to state in number 1 what is that rate of change, because that's the pattern that we see. It's going to look like a line. It's going to look very much like a line because we have 0, 0, right? Then we have 1, 2, 3, 4. So let's go 2, 4, 6, 8. So we have 1, 2, 2, 4, 3, 6, and 4, 8. All right. So we graphed it right there. We graphed the ordered pairs. But I'm still not talking about whether or not these things are discrete or continuous. It doesn't really matter at this point. What's important is to label the axes. So y-axis over here versus the x-axis right here. So our y-axis, we're going to label that, since we're talking 2, 4, 6, 8. So we're going to label that for number of songs. And our x-axis, we're going to label time in minutes. Right? Boom. There we go. So let's move into the next page, and this is linear relationships. Linear relationships. So we start us off with definition: relationships that have straight line graphs like the one on the previous page. All right, because if this happens to be continuous, this one's not, it's discrete, but if this were continuous, then we could draw a line and look at that. Golly gee willikers, that looks like a line. So we call that a linear relationship because X and Y, they're related in a way that looks like a line when we draw the graph. So the rate of change between any 2 points in a linear relationship is constant. All right, so that means it's the same. So as we saw here, every time we go up by 1, from 0 to 1, from 1 to 2, from 2 to 3, the number of songs is increasing by 2. So it's a steady 2, which means it's the same or constant every time. So you have a constant rate of change. All right, example 1, they tell us about an account balance. They say the balance in an account after several transactions is shown below. And the first thing that jumps out at me when I'm looking at number of transactions, which is really our X, versus Y, which is our balance, right, in dollars. So what I notice is from 3 to 6, I'm going up by 3, by 3. by 3. So if we're going to notice a linear relationship, then what we should see is a correlation between these output values. So what kind of correlation am I looking for? Well, if I'm going up by 3 from 3 to 6, all right, I am dropping 30 right here. Now I'm going up from 6 to 9, so I'm going up by 3 again. So what I'm hoping to see, if this is a linear relationship, I'm hoping to see the 140 minus 110. All right, ooh, look at that. That's 30. All right, but it's not positive 30 because we're talking about what's happening to the balance of the account. It's it's decreasing, so that's why it's going to be minus 30, minus 30, minus 30. But then we just want to check it out again, right? So from 9 to 12, if I'm adding 3, then I come over here and look at this, 110 to 80, we're dropping $30. So we have a consistent amount, right? That amount, $30, it's staying the same or constant. So that means we have a linear relationship and we're dropping $30 every time we do 3 transactions. So please don't tell me it's $30 per transaction, guys. Use your knowledge of arithmetic and simplify this. So this simplifies to $10 for every 1 transaction. All right, so what is our slope? Our slope, or our rate of change, is 10, right? $10 per transaction. All right, let's take a look at the sample problems right here. Cooling water. All right, so we have time and temperature. All right, so what's happening right here? So our time, we're going up by 5, 10, 15, 20. And what's happening with our temp? Well, we start out at a high of 95. We drop to 90, so that's minus 5. As we go up from 10 to 15, so we're going up 5. Ooh, guys, we're only dropping 4. That's a problem for us. From 15 to 20, we're going up 5. That's consistent. But from 86 to 82, we're dropping 4 again. So dropping 4 versus dropping 5, this is, this does not have a linear relationship because our rate of change is not constant. For it to be constant, these two would have to be -5 or stay -4, and this would have to be -4. Since it's not, we do not have a linear relationship. All right, what about B? Well, we have ourselves a graph, and we're looking at time in minutes on the y-axis versus number of volunteers over here on the x-axis. All right, now it looks like we have 8 and 80. Don't know if we can draw any conclusions from that. And they take us out to 16 and 24. So we have 16, 60. So as we go up 8, we're dropping 20. And then what happens at 24? Well, 24 is out here at 40. So what did I do? I jumped up 8 again as I'm going from left to right. And what's happening to the y-axis? Well, from 80 to 60, I dropped 20. From 60 to 40, I dropped 20. So guys, we have consistency right there. All right, consistency. So we actually have right here, we have a linear relationship because our rate of change is constant. All right, so we're dropping in time as the number of volunteers increases, which kind of makes sense, right? Because the more volunteers you have should take you less time to get something accomplished. All right, so what's happening there with this negative correlation is if we're dropping 20 volunteers, I'm sorry, if we're dropping 20 minutes every time we increase the number of volunteers by 8, so we are dropping 2.5 minutes off of our time every time we increase by 1 volunteer. So our slope, or our rate of change, is negative 2.5 minutes per volunteer. Because once again, because that's what we're saving. right here in terms of time, we are saving 2.5 minutes every time we increase by 1 volunteer. All right. Let's take a look quickly. Proportional linear relationships. So that's on the next page, 401. Two quantities A and B have proportional linear relationship if they have a constant ratio and a constant rate of change. So if B over A is constant and change in B over change in A is constant, we have proportional linear relationship. So we just compare the ratio B over A for several pairs of points to determine if there's a constant ratio. All right, so what's going on with our example problem? We go to temperature, right? So we have degrees Celsius, degrees Fahrenheit. So degrees Celsius, we're going up by 5, 0, 5, 10, 15, and 20, all right? And you see this in your lesson. They point this out. All right, now what's happening to Fahrenheit? 32, 41, 50, 59, 68. Ooh, look at that. Plus 9, plus 9, plus 9, plus 9. Well, it certainly seems like we have a linear relationship. All right. Now, what about a constant? Right? So what's happening right here is if every time we increase Celsius by 5, we increase Fahrenheit by 9, they said go ahead and check to see if things are going to be consistent right here. So our B over A, right, is 9 over 5. And if we go and look at the change, right, as we go from 0.32 to 41.5, if we look at how this thing changes over time, well, let's see if the ratio stays consistent, stays constant as we go from pair to pair. Ah, geez, guys, that's going to be a problem for us. Because what we see here is, right, 41 over 5, it's 8.2. All right, so if we're thinking 9 to 5, right, that's it's like 1.8 per. So here it's 8.2, 50 over 10 is 5, so 59 over 15 is approximately 3.9. So the ratios as we go across, they're not the same. So even though it seems right here like, oh, the plus 5 and the plus 9, right, so it's looking like it might be linear right there, and it certainly looks like we have that constant rate of change, but our ratios are not the same. So our relationship is not going to be proportional. All right, so it can be linear, just not proportional. All right, because it's not going to be like this, right? It's not going to be like y equals 9/5 x. It's going to have an additional piece right here.